Write down. Reaction of this with phenol. NaOH, what is the product form? So we form O negative Na plus. If you bring carbon dioxide to react with this, ये तो समझ में आता है सबको? Chinmay, I think this is simple reaction. H is being taken out. What is be the outcome here? Reactions of phenol. How will you do this reaction? How will you write this reaction? कैसे लिखेंगे? Shravya, what should we do? We have O negative, we have the structure, we have CO2. What can happen? So which mechanism, which reaction mechanism is to be used here? Addition or substitution or elimination? पहले बताओ इनमें से कौन सी mechanism होगी? Which one? Addition, substitution or elimination? First figure out that. Elimination. क्या eliminate करेंगे आप? Answer is substitution. First of all, you should know that substitution has to happen. It's a benzene ring. You can't do addition on ring. You know very well. Benzene ring is not open for addition. It's not a normal double bond. There is nothing to eliminate also in this case. So we have to do substitution. Now, next question is, if it is substitution, is it electrophilic, nucleophilic or free radical? See, why I'm telling you these things? Because these are some basic common doubts which we normally ignore कि अरे आपको समझ में आ रहा है, but actually समझ में नहीं आ रहा होता है, right? So I'm just going little more basic, okay? Looking at your school performance, test performance, all the performances, right? So अब कौन सा इसमें से टिक करोगे आप? Electrophile, nucleophile और free radical? Which is correct option? This is there, this and this is CO2. So which one you're going to mark? How many say electrophile? Raise your hand. How many say nucleophile? Repeat the question. My question is, ये reaction हो रहा है. ये reaction एक substitution है, but substitution of which type? Out of these three, which one? You have to mark. So what's the answer? Answer is, substitution is electrophilic. Because C double bond O2, CO2 is basically acting as an electrophile. This bond can break and this is delta minus and delta plus. So this is electrophilic location. ये basic चीज आपको समझ में आनी चाहिए पहले तो. ठीक है? Now the next question is, substitution is there, electrophilic is there. So what will be the mechanism? O negative is a group with which all effect? Tarun will answer. O negative is a group with which all effect? Don't see. Plus I and? Plus I and plus M. Very good. So it's a plus I and plus M group. Please write down. It's a plus I plus M group. ये plus I plus M क्या होता है भाई? Plus I means it will push electrons. Okay. Push electron, it will supply electrons. But being O negative, why it is supplying electron? Because O negative is having plenty of electrons, right? So it starts giving electron. Are you understanding? And why is it plus M group? Because it activates ortho and para position. How will it activate ortho and para position? Via resonance. Okay. So if you see this negative, if it moves here, this comes here. So at this position we can have electrons. Similarly, if this moves here, this comes here, this position we can get electrons. If this moves here, this gets electron. So these three positions are electron rich position. I hope that also is understandable. So what should happen in this process? In this process, substitution electrophilic reaction is happening and it will act like this. So O negative is given. You can attack on CO2. Bonds can break. There is one H, do not forget that. Answer is a double bond, double bond, double bond. At this position, one hydrogen, one carbon with O negative, one double bond O. Can you draw this much? Anyone having any problem with this part? O negative? O negative तो नहीं प्लस के साथ ही है ना यहाँ पे. You're saying O negative directly attacks on CO2. Okay, that's again a question, but yeah, what's the answer for this? You know the answer for this. If O negative attacks on CO2, which reaction is that? What will be the reaction? If O negative attack on CO2, which reaction is that? Nucleophilic addition reaction. कौन सी रिएक्शन होगी वो? न्यूक्लियोफिलिक एडिशन रिएक्शन. चलो मान लो करके देखते हैं. पहले तो समझो न्यूक्लियोफिलिक एडिशन के लिए आपके पास होना क्या चाहिए? न्यूक्लियोफाइल होना चाहिए. Is phenoxide ion a good nucleophile? Answer is no. It's a highly resonated structure. O negative is moving all across the ring. So is this O negative concentrated at a particular position? You can act as a nucleophile, go and attack with this? Answer is no. We can't do that. So what are the best possible scenario which we are doing right now? Do you get the answer? Okay. And मान लीजिए अगर अक्षय जो बोल रहा है अगर वो कर भी लेते हैं हम लोग, मान लो जो बोल रहा है एक बार हम ट्राई करके देखते हैं. गलत बात नहीं को आपके डाउट सॉल्व होने चाहिए. मान लो आपने अटैक कर ही दिया, ऐसा बना भी दिया. Let's say, for instance, so what is the next step? In the very next step, this is again out, and it will go to the normal because OC bond है आपके पास. OC bond can cleave easily, and we have a stable CO2 coming out of it. So why will I join there? You get the point? In simple words, OC connection is better or CC connection is better. CC connection is any day better, right? So all these answers lead to the same logic that this is correct and there is no other option. Okay. चलिए वापस आ जाते हैं इस पे. So what will happen next? This O minus is here and H is here. So you can say that this negative oxygen can grab this edge, create a double bond and set it free. So you are reinstating the resonating structure and the final outcome will be we have a O negative, we have a double bond. At this position we have COH and double bond O. Now, this is a good acid. COH is a carboxylic acid. Okay. Acid with a K value of how much? RO. इसका K value कितना होता है approximately? In which range? 4 to 5. COH का K value is 4 to 5 range. Acetic acid pK is how much? 4.74. आने पड़ी आप सभी, right? You have done आने की क्यों? So this is in 4 to 5 range. Now what can happen? It's a good acid. This is O minus, which is in the range of 9. So H should not be left on good acid. What's my final answer? My final answer will be, we can draw one OH and we can put COO negative. ये आपका final answer बन जाएगा. कर पाओगे? So this reaction has a name. It is called, what is this? You have done earlier Kolbe's electrolysis in alkane. This is Kolbe's reaction. These are two different things. This is Kolbe's reaction. That was Kolbe's electrolysis. Anybody remembers that reaction? What was Kolbe's electrolysis? RCOO negative Na plus. If you take it under electrolysis, this used to give you RR and then they combined to form RR. Same as a Wood's reaction product. Can you remember that? Do you remember that? Please note down. A good acid will always try to provide H. This is a good acid COH. There's a nearby requirement is there O minus, you can always transfer it. Yeah, that's okay. So it will form what? It will form CO negative. Resonance वैसे भी चल रहा है इसका. यहाँ पे अगर OH आ गया, यहाँ पे C double bond हो O negative. You are forming a carboxylate. It is also a stable structure. Any problem in this part? Is this reaction clear? Is this reaction clear? पूरा समझ में आपको? Can I remove this? Diti, is it clear? Any confusion? Anybody? Any problem? Okay. Let's write next reaction. Can I remove this? Okay. एक और reaction try करें. So let us suppose you are given a question. O negative, and then you are given HCHO. Now please answer what will be the possibility in this case. O negative and HCHO. What all options do we have? So same logic, this moves, this attacks, this breaks. What will it become? Double bond O. At this position, one hydrogen is there. Can I say it's same on previous lines? This is the last question. What will O minus do? Grab hydrogen, create a bond, and this is free. So what is the answer? You will end up getting O negative and a CH2OH at this place. How many of you agree with this? Do you understand this detail? Is it same as CO2 reaction? Yes or no? This was CO2. Then you form C double bond O minus. This time it is CH2O double bond. Sanjana, is it clear? Any doubts you can ask. Let's say it is given one more mole of HCHO. Now what is going to happen? The same compound. I'm just writing it here. Again you are giving HCHO. अब कैसे करोगे आप? This will move. Now this can attack. See, this you have used already. So can I say this can attack with para position maybe? Yes or no? अब क्या बनेगा? Please write these mechanisms. Now it is high time that you understand the mechanisms, how to write. अभी आप छोटे बच्चे नहीं हो. You know all those things, right? You should know how these things work. This grabs edge, again form, give it back. So can we reach up to the same answer? O negative with CH2OH and CH2OH. Para position पे लग गया. Yes, that is the next step. And again, if I give one more HCHO, now phenoxide is highly reactive thing, right? And moreover, ortho position is activated position, para is activated position. So it again puts one more and it becomes this structure. Now I'm coming to the point why I'm drawing the structure. There's a reason for it. Any issues? Now the compound which is in front of you, its polymerized form is called Bakelite. And Bakelite is a very important polymer which is formed by reaction of phenol and formaldehyde. Phenol and formaldehyde. What is HCHO? HCHO is nothing but formaldehyde. So please note down the whole thing. I have shown in form of a reaction, but this is basically formation of Bakelite. So if they ask how Bakelite is formed by reaction of phenol and formaldehyde. Okay, formaldehyde is this, and in this process you are repeating 3 HCHO reactions to get this thing. This is not Bakelite. Bakelite is polymer form of it. Now how it is polymerized, just to show you. So let's say this is one ring, CH2OH, another ring, CH2OH, another CH2OH, and then later if you give it H or something, it can become OH, right? Now just copy this unit one more time. CH2OH, CH2OH, OH, CH2OH, right? And let's say another unit is here. OH, CH2OH. Nobody's going to ask you that, but you can see the diagram and you should be able to at least understand that this is a Bakelite structure. Okay. So I'm writing multiple structure of it, and nearby structures eliminate water and club. Cross-linking hoti jaati, and it forms a three-dimensional product, which is called bakelite. Fine. Again, nobody's going to ask you to draw these structures, but at least you should know bakelite is formed as a polymer of this unit, and this unit is formed when phenol attacked with HCHO 3 units. One for ortho, other for ortho, one for para. I hope the whole discussion is clear. This reaction is also on the previous lines only. So whatever you're doing right now, everything is based on which mechanism, कौन सा mechanism पे बात कर रहे हैं हम लोग? First answer, substitution, addition, elimination. यथार्थ, what is it? Is it addition, substitution or elimination? Substitution. Is it substitution electrophilic? Electrophilic. And if you want to be further sure, you can say aryl, because on aromatic ring you are using substitution. Start recognizing mechanisms, which mechanism is happening where. That is the first step. Okay. And now you all are having maturity of understanding these things at a higher level, right? So you should be able to do that. Is it clear? This is formation of bakelite.
So it's para.
It can attack para, no? Already attack para.
But it will be also para.
See, sequence you can decide. It's okay, right? It can be a case where ortho, para, ortho, all kind of possibilities will be the reactions happening, right? So it's not a fixed way that first you have to do ortho, then it has to go para only. All possible scenarios will be there. Ortho is slightly better, right? Yeah. But already one ortho is there. That's why I'm running another ortho immediately. I'm drawing para and then ortho. Fine. So any problem in this part? Any issues? Which reaction is this? Substitution, electrophilic, aryl. Easy question. Bakelite formation कर लोगे, Kolbe's reaction कर लोगे, दोनों चीजें समझ में आ गई. Akshay, is it clear? Adya, clear? Clear? Okay. Any doubt in this part? Any issues? Any problems in this part? Tarun? Can I go to the next reaction? Yes, please note down.
The reason H doesn't attack O minus is because O minus is like dispersed. There.
H did not attack to?
O minus the carbon. Because of that.
In this case? Yeah, so basically see, last case was COH acid, right? So acid was deliberately giving its H, right? This time I have alcohol, which is not that great acid. So I'm not putting that H to other side. Fine. Any issues in this part? अब देखो 2-3 reactions आप फटाफट समझ जाओगे. Can I remove this? Done? Anybody writing? Okay. Come to the next reaction. Yes. Where will it go? First of all, which reaction is this? NO plus is an electrophile. So again, the reaction is SEAR reaction. SEAR reaction, how will you proceed? So this can go, this can attack here. NO can join on ortho position. So after doing all reactions like this, okay, later you can remove H. Can you do all those things, right? So what's the final outcome here? Final outcome is O negative यहाँ पे रहेगा और यहाँ पे आपको एक NO आके लग गया. कर लो, सिंपल सी बात है. कौन सी mechanism हो गई? Which mechanism is this? SER. If somebody gives you NO2 plus, अब क्या करोगे आप? O minus, NO2 can join. Chinmay, is it clear? If this is possible, you can ask a fair doubt that, sir, why not para is also involved? Yes, para is also correct. ये भी बन सकता है. And यहाँ पे भी para बन सकता है. बिल्कुल बना दो. We'll talk about it. First, formations are clear. Okay. Ortho para both can be formed, right? Any issues in this? How will they give you NO2 plus? They will not write NO2 plus. They will give you HNO3. And you have to understand HNO3 is provider of NO2 plus. They will not write NO plus. They will write HNO2. HNO2 is provider of NO plus. How it is, I'll discuss that also. But I think you understand that they all are going on the same line. First reaction you have seen for CO2, then you have seen for HCHO, then you have seen for NO plus, then you have seen for NO2 plus. Are you finding any difference in these reactions? Are we supposed to spend a lot of energy understanding this? No, they're all same reaction, SEAR mechanism. Do I need to mug it up? Answer is no. Electrophile लेना है, आपको ortho para पे attach कर. And bond movement you know. Can I do that? Yeah, NO plus N. NO plus का structure कैसा होता है? N oxygen. चलो सब लोग बनाओ एक बार. Lewis dot structure बनाओ. Try to plot Lewis dot structure of NO. देखो जरा chemical bonding कितना याद है आपको. Try to complete test on Quizzer. Okay, आपका टेस्ट पेपर Quizzer से ही होगा. Quizzer के सारे टेस्ट अगर आपने लगाए तो आप फुल स्कोर कर सकते हो. एटलीस्ट केमिस्ट्री आई कैन टेल. फुल मतलब फुल सारे चैप्टर टेस्ट जो आ रहे हैं, टॉपिक वाइज टेस्ट एंड PYQs पूरा सॉल्व किया हुआ है, सो यू कैन स्कोर फुल इजी. सो स्टार्ट सॉल्विंग. पेपर पहले ही बता दे मैंने आपको. अब जिन्होंने क्विजर देखा ही नहीं आज तक, लॉग इन ही नहीं किया, दिस इज अ हाई टाइम टू लॉग इन. कितने लोगों ने टेस्ट लिखा है क्विजर पे इस एकेडमिक ईयर में, इन दिस एकेडमिक ईयर? देखिए पक्का. हाउ मेनी ऑफ यू हैव रिटन टेस्ट in this academic year? How many of you have not written any test in this academic year? When I say this academic year, starting from April 1st to date. How many of you have written more than 10 tests in this academic year? More than 10. Okay. More than 20. More than 30. 40. 50. 60. 70. 80. 170 टेस्ट लिख दिया इसने. 170 टेस्ट he has written. So you should get full score now. Yes or no? पेपर तो वहीं से आ रहा है. सारे टेस्ट एक बार अपने रिवाइज करिए. This is open. See, I'm giving you same what do you call equal feet, right? Equal level, so that you should nobody should say later कि नहीं पता. मैं बता रहा हूँ. क्विजर के सारे क्वेश्चन सॉल्व कर लो. चैप्टर जाओ, अल्काइल हैलाइड टॉपिक वाइज टेस्ट सारे सॉल्व कर लो. कंप्लीट what do you call chapter test, complete PYQs, mains level, advanced नहीं पूछ रहा हूँ, mains level तक आप सारे कर. Same you do for solution and colligative. इतना हो जाएगा तो अपने आप आपका स्कोर भी आ जाएगा. Anyways, how do you draw NO? You're asking something.
Which be the major protocol?
Out of these two, I'll come to major also. First, you tell me the NO structure.
The H doesn't attack romance. Doesn't attack home.
No, my question is different. My question is first you draw this. Huh?
Does it attack?
Just answer this. How will you draw NO?
Yeah.
देखो कितने लोगों को केमिकल बॉन्डिंग याद है. Oh wow, and double bond. Oh,
Line.
and plus charge. So नाइट्रोजन पे इलेक्ट्रॉन्स काउंट करना एक बार. हाँ जी, कैसे बनेगा NO? गलत है, wrong. NO. So if you draw NO, just count electrons on nitrogen. No, I said NO. How can count electrons on oxygen? But oxygen outermost, how many electrons are there? 6. Where is 1 electron on oxygen missing? Nitrogen outermost is 5 is fine, but oxygen 6 is there, no? So where is 1 electron? स्ट्रगल हो गया था पूरा. NO का स्ट्रक्चर ही स्ट्रगल है. संजना जी क्या कर दिया आपने? एंड डबल बॉन्ड बना दिया. इनका देखो सिंगल बॉन्ड पे ही चल रहा है अभी. आपका अभी स्ट्रक्चर N लिखा जा रहा है, अभी तो शुरू हुआ है. हाँ शाव्या जी, केमिकल बॉन्डिंग पढ़ाती जाए लग रहा है। 11 के साथ अटेंड करोगे, केमिकल बॉन्डिंग शुरू होने वाला है। हाँ, कोऑर्डिनेट बॉन्ड बनाइए। So correct answer is oxygen has outermost how many electrons? 6. Nitrogen has how many electrons? 5. If you connect these two, this has become 7 and this has become 6. ये समझ में आता है? If you connect these two, this has become 7 and this has become 8. Now oxygen is no more interested in any further covalent bond. अभी 9 पे थोड़ी लेके जाओगे ऑक्सीजन को. So what's the only option? You have to use coordinate bond as Arav has mentioned. ये coordinate ऐसे आएगा. Coordinate bond will maintain this 8, but the problem is when you send coordinate, this 7 will become 9. 9 is not acceptable. Okay, that is why we say NO becomes NO plus after removing that extra electron and becomes more stable. There's a reason behind NO becoming NO plus. So NO plus will have loss of one of the electron. You can remove one of the electron, then it is fine. That is NO plus. But NO structure will be this only. Oxygen put a coordinate bond. This is NO structure. If somebody say NO draw करना है तो ये draw करोगे आप. And then you can show the remaining electrons. Is it clear? If they say NO plus draw करो, which is a right 8 octet completion मिल जाएगी. When you remove this electron, then it is NO plus. आ गया? Any problem? So what is this NO plus? NO plus is an electrophile. NO2 plus is an electrophile. Ortho para position पे आप attack कर सकते हो. Now, as we know, O negative is a plus I plus M group. So frankly speaking, it will invite incoming electrophiles on ortho. Ortho is a better position, okay, for all the attacks. But don't invite someone who can be harmful. We invite to kar liya. After invitation, if it is destabilizing it, then again a problem, right? So that also have to consider. Is it okay? But yes, ortho you can say as major in all the conditions. But if I put 2 NO2s here, then the structure becomes destabilized. Utna stable nahi reh pata. Okay? If it is O minus, it will invite, but yeah, fine. You should take care of that part also. Now, is this clear, everyone? This will come in coordination compound again. So that time I will try to avoid that discussion of NO and NO plus. NO plus is also electron donor because it still carries 2 electrons. And NO is also electron donor because it carries 3 electrons to give. These things will come in coordination compounds. Okay. All these reactions are fine for everyone. Great. Let's see a few more reactions. Can I remove this? Any doubt? Please draw this compound. Try this question, please. Try this. Just try without any name. Think what is possibility. So what do you see in CHCl3? It's a chloroform. What do you see in tertiary butoxide? It's called tertiary butoxide. Okay? It's a base and bulky base. How many of you are capable of drawing this structure? इसका structure बना सकते हो आप? कोशिश करें. Alkyl halide पूरी पढ़ चुके हैं आप. Alcohol phenol ether is towards the end. GOC you have done. Butyl you understand. Tertiary you understand. So can you please draw the structure of this compound? How many of you can draw the structure of this compound? It should be O negative and carbons like this. कितने लोगों ने draw किया? You can put CH2. Right? This is tertiary butoxide. Why it is tertiary? Because it's a 3 degree. And why it is butoxide? Because O minus and K plus will be next to it. So this is a bulky base. Any problem? This is a bulky base. First of all, it is a base. Keep in mind. So base का role क्या होता है? Take H plus. Tarun, base का role is take H plus. Do we have any H plus which can be taken up? You have CHCl3, you have this compound. So CHCl3, this hydrogen can be immediately taken up. And this can convert into CClCl minus. Likewise, this hydrogen can be immediately taken up. This can become negative. Base given है, base अब ऐसा नहीं कि एक ही यूनिट दिया base का बस एक बार अटैक करना है, ऐसा तो कुछ मेंशन नहीं. So base is there, it can do that. Okay. Can you do these two things? Benzene H is CH hydrogen. NH hydrogen and CH hydrogen, what is the key difference? Nitrogen's electronegativity of the order of 3. And carbon, you know, is very low in the table, right? So CH bond will be having less polarization. You can't break it. NH bond you can break. Electronegative elements. This H. ये H. हाँ, दोनों ले रहे हैं, मैं दोनों ही निकाल रहा हूँ. See, why this is being taken up? Because minus charges delocalize in vacant 3d orbital of 3 chlorines. So CHCl3 is a decent acid in that way. And here also it can be, because this is a very strong base. That's why I'm not using a normal base. I'm using a very strong bulky base. It's a very strong base, right? So it will solve both the purposes, right? What will happen next after this? So this is CCl3, and as you can see this reaction, this is aromatic structure. This is also aromatic part, right? And aromatic rings are not prone to any kind of addition reaction. Right on the slide, aromatic compound is not prone to addition reaction. So addition is not an option. Yes or no? So what are the options for us? We have option of substitution. Considering substitution option, you know that this is a rich ring. So I need someone which is poor. This is rich, this is rich. Rich cannot attack rich. It needs poor to be attacked. Poor कैसे बनाओगे इसको? You will remove Cl negative. Formation of dichlorocarbene. No, carbene. Dichlorocarbene. And carbenes are electrophilic in nature. यहाँ तक समझ में आया? So we form dichlorocarbene, we have N negative, and this is the situation right now. Now, once you get this situation, so what are your options? Your options are, you take dichlorocarbene and go and attack somewhere. Okay, so where we can attack, that we have to observe. But before that, can we say, nitrogen, same problem of O negative, which we discussed. O negative directly going to nucleophile is not an option. Same logic. Abhi pucha tha usne action hai. Same answer for the same question, right? So what are the options? You have to have options like okay, if this pushes, this position is free to attack where? CCl2. Think about it. Kar sakte hain? So what will happen? This is dichlorocarbene. So what will be the option? This will result into N double bond, single bond H, C, Cl, Cl and negative. Okay. What is the next step? C negative can capture hydrogen, create a double bond and make it again N negative. हो सकता है ऐसा? Possibility तक है? Okay. अगर ऐसा हुआ तो क्या बन जाएगा? So you'll get on this carbon, I have CH, Cl, Cl. Can I get this structure? Any problem? And if let's say there is supply of OH minus later, I could also change these Cls to OH, and 2 OH can become double bond. ये सब पता है आपको? This part 2 Cls can be 2 OH if I attack with OH. After this, if I provide OH minus, what can happen? These can become, and then 2 OH can become C double bond. So what is the final outcome of this reaction? We end up getting this kind of product, which is a Reimer-Tiemann product. Not abnormal. It's a normal reaction, right? CHO aa raha tha, CHO aake lag gaya. You have done Reimer-Tiemann reaction in the last class. Chinmay, you have not done, but now you have done. Because this is what is Reimer-Tiemann on O negative, same reaction. So, whatever we have done, we got CHO. In Reimer-Tiemann, what we do? O negative, ortho position we put CHO, para position we put CHO, and almost similar reaction mechanism is there. Can you follow that? So this is a normal RTR reaction which this particular compound can do. The name of this compound is indole. Indole. अब नाम कोई आपसे नहीं पूछेगा तो उसकी टेंशन मत लो. Okay. So this is the process with which you get this particular option. Now I will show something different which is called abnormal Reimer-Tiemann reaction.
Nitrogen be charged.
Yeah, you see, eventually the base is taken H. Huh?
Product.
Yeah, N will have H, right? In the
The N has an H.
yeah, because see, N was having H initially, no? You've taken H with the presence of base to activate the mechanism. Now base has taken, so Bu, once it takes H, what it becomes? BuOH. Can we say these BuOH are present in the reaction? While ending the reaction, while closing the reaction, I don't want charge on the product, right? So N minus captures this H and you get the final answer, right? Is it doable? Any difficulty in this part?
You're getting HCl and that OH that into the car.
Yeah, these Cls are replaced by OH. These Cls are replaced by OH and then 2 OH give you double bond. You know that. Hence, on the place of Cl, I will get CHO. Is it making sense? Yeah, you have to provide those OH. Basic medium. See, one option is I can say this is tertiary butoxide. It's not like that you have just this material, right? Along with that, you're supplying OH minus if you want. If you don't supply OH, this will be a final answer. यहीं पे रुक जाएगा रेश. Is it clear? Both the Cls are replaced with SN reaction, substitution nucleophilic reaction. They both become OH. And on same carbon, 2 OH cannot stay. What will they do? Yatharth. Which reaction will happen? If 2 OH are on same position, which reaction will happen? Addition, substitution or elimination? Elimination. Which elimination? Alpha elimination. 1-1 elimination. Same carbon 2 OH, one will push, other is going out. Water will come out. Water will come out. So it becomes a simple double bond, which is Browning. I hope the whole process is clear. Remember, this is a normal RTR reaction, normal Reimer-Tiemann reaction. Now we will see abnormal. Abnormal is more important for a difficult mains level question or a easy advanced level question. Okay. But of course, not important for your board examination or school examination. But you can understand it. It's not that difficult also. That's why we can mention and close this discussion. I hope all these aspects are clear. How do we write mechanism? See, your take home should not be that you just mugged up that this becomes this. I don't want that. I want you to realize that what is the thought process. If you can reflect upon thought process next time, then everything is sorted. Even if you don't know the product, it's okay. Even if you don't know the reactant, it's okay. Even if you don't know the name of reaction, it's also fine. As long as you understand what is happening here. Because that will help you in longer way, right? Today, tomorrow, day after, you will understand the whole mechanism also with practice. But if you're not understanding the concept, then that is a problem. So how many of you realize that what is happening in this reaction? Step by step, what is happening, how happening, what are these steps? Are you getting clarity on that part? That is most important take home message. Why does? Yeah, because see, I have to proceed, heat is given. So heat itself is a cause for this kind of option because I have to proceed with the reaction. A rich cannot join. So there is one option, I say no reaction will happen. But to do the reaction, this is the only way out. Okay. Can we move to the abnormal part of the reaction? Abnormal RTR. चलिए देखते हैं. So abnormal RTR कैसे होगा? ये सब कुछ ऐसे रहेगा. Everything is as it is. The only difference is, can I remove this part? If you have written the options, so I'm just removing. Huh? Carbene is reactive. Carbene is reactive. So now I'm just doing abnormal part. That sideways one more reaction will start. This is one product we have written. This is one of the product. Now other product and how it will form. This is available. Heat is given. उसको आप आराम से ड्रॉ कर लो पहले. Now carbenes and a lot of heat is given in this reaction. So what happens? This particular double bond shows free radical addition. Okay. Basically, it's a free radical reaction which happens here. So this double bond breaks, negative, like radical clubs here, radical clubs here. What is this called? This is called cyclization process or zation. Cyclization via carbene. Okay. Please draw this. As I'm saying, abnormal. So आप देख भी सकते हो थोड़ा abnormal हो रहा है step पे. Right? It's not normal step. What will happen because of it? Because of this, the structure rearranges too. But reaction won't stop here because this is a three-membered unstable formation. Three-membered unstable formation. Now, first you draw this much, then I'll show the next step. Any problem in this part? Double bond था उस पे आपने CCl2 add कर दिया. You have seen these reactions. What's happening? No. This is a byproduct of this reaction only. So, see, the question can come, this is one product, what is the other product that can be formed? That I'm trying, right? That I'm trying to draw. Are you understanding? But again, this question is more reasonable question for a difficult JEE Mains level or an easy advanced level. Okay? Just giving you an idea like where exactly this can be asked, right? Of course, not in your school exam. Okay? See, whenever you have carbene and you have a double bond, cyclization is a possibility. Double bond and carbene can always club and form cycle ring. Now, heat is involved. This heat is major factor and this strong base is making these things valid. So because of this heat, there are three things. You can locate a leaving group. I'm not happy with this three-membered ring. We don't want this kind of three-membered ring. We have ring expansion options and see how. N- pushes electron. This ring breaks and this goes out. Facilitation, migration and leaving. This is facilitation. This is migration and this is leaving. FML, can you remember this? Do you remember this FML? Earlier we have done multiple times. Something facilitates, some migrates and then leaving group. If this happens, can you redraw the compound after this? The compound will be rearranged to a 6-membered ring. Now see, this is nitrogen with a double bond. Don't forget this carbon. So ये वाला carbon हो गया. Then there is another carbon. ये carbon हो गया. On this carbon there is a Cl. ये Cl हो गया, right? And then this is becoming a double bond. See, this bond is breaking and going here. So it's a double bond. And then this point is attached here. So it's connected here. Basically, you get a 6-membered ring. Now a 5-membered ring is becoming 6-membered ring. Welcome, move. तो ये भी possibility बन जाती है. Your final answer can be a ring, nitrogen with a ring and a Cl. This is the final product. Sure. Is the first step clear? This 3-membered ring is not a good option which is formed. If this bond breaks, यहाँ पे double bond आएगा. Carbon cannot hold 5 bonds. So 1 Cl can go out. So ये double bond आपको यहाँ पे दिख रहा है. Who is the facilitator of this push? कैसे शुरू हुआ है सब कुछ? N negative pushes electron, this bond breaks. Why this pushes? Because N negative heat is mentioned, right? And here forms a double bond. Why it forms a double bond? Because these electrons are moving here. I've shown it. Clear? So ये double bond, and then this is open. This is single bond. On that, one chlorine is remaining, and then a double bond. This is the product. This is called abnormal RTR. Abnormal RTR. Normal RTR, abnormal RTR. पूरा मैकेनिज्म समझ में आ गया? Shyam, is it clear? Any problems, any issues? Anyone having any difficulty in this part? Now take a moment, try to check what all you have done so far in today's class. You've done a lot of important reactions here. So just have a look at it. क्या क्या आपने किया है? Kolbe's reaction हो चुका है, Bakelite formation हो चुका है. Good. Any doubts you can ask. Tarun, any doubts? Any questions?
This is the minor product.
Which one?
This is the minor product.
Abnormal RTR, yes, it is a minor one. Okay. Majorly you will draw this, and this is another byproduct. Clear? Any problems, any issues, any difficulty in this part? Okay. Yes. Substitution electrophilic is, let's say you have a double bond and you attack E plus on that. But if you have aromatic compound, we categorize it SEAR. No, all reactions are SER. All are SER. I've written SE, but AR is everywhere because all are aromatic rings, right? Even this was also example of AR. Yes. C double bond to O negative, and O negative, you're saying O negative is better option. Which is COH? COH is a group which is having pK value of 4 to 5. Phenol is having 9 to 10. So which is better acid? COH is better acid. So where should H be? To OH, not on COH. Okay. Right. Next reaction. Right now. Yes, yes, after this. What is the product in all three reactions? Starting substance is benzene. What will be product in all three reactions? Everywhere is starting with benzene. Raunak, what will be answer for first one? So AlCl3 is the lowest acid. अब देखो fundamentals को फिर से एक बार बात कर लेते हैं. This is the lowest acid, and lowest acid will always look forward for some donation or support. Chlorine nearby can coordinate it. Because of this, this will polarize and break. This is a plus charge and this is a minus charge. Yes or no? So what we get is we create a carbocation which is CH3, CH plus CH3. This is a 2-degree carbocation. Can we rearrange it? Can we make it 3-degree anyhow? In this case, answer is no. This is a 2-degree carbocation. This is an electrophile. Benzene ring is given. So what should be the final outcome? क्या करोगे? Benzene ring पे इसको attach कर दो. भाई इलेक्ट्रोफाइल ऐसे अटैक कर देते आप. प्रोसेस आपको पता ही है. कौन सी मैकेनिज्म हो जाएगी? Which mechanism is this? Is it addition or substitution or elimination? Is it addition? Benzene is not open for addition. That's what I'm repeating. Substitution. See, why it is substituting? Because H is going. In place of H, this is coming. H जाएगा, H की जगह पे आ रहा है, right? Substitution. If you want to recollect the whole mechanism, you can say like this. This is benzene ring. You bring any electrophile. It attacks. It forms this kind of structure. H and E and a plus charge. Then we show multiple resonating options for this case, right? That this moves here. So it is like this. Plus charge is here, double bond here, He. Next time somebody says this moves here, then it will be this. Double plus He. Okay. Then we draw plus charge is moving everywhere. ये सब याद आ रहा है? पढ़ा है आपने GOC में क्या? You have done in GOC. And then in the final step, what we can say that H is out and it is just E attached here. Just E attached here. So basically, किया क्या हमने? We just removed this H and put E. That's what we have done. Is it okay? Is it fine? So in this case, if you're doing it, if you're just removing H, putting E, that's what I'm just putting the whole thing at some place. Any place, all are same for me. The name of this compound is cumene, not cumin. Cumin is used in kitchen. ये cumene है. Note down. What will happen in second question? Second question, what will happen? This is double bond. H plus is given, so this will attack. You will have CH3, CH, CH2 will grab H, plus charge will come here. So what's the answer? Same answer. And the last case, Cl minus will become AlCl4 minus. This will be a plus. This hydrogen hanging here will do hydride shift and again form this and again form this. Can you do these things? How many of you understand all three of them will end up with the same answer, cumene? Cumene पे छोड़ के गए थे ना? Cumene याद है? How will cumene form? If you're given benzene and reacting with any of those three reactions, it forms cumene. Now, cumene with oxygen heat or oxygen sunlight, what will it form? That's the question. So whenever you given oxygen heat or oxygen HT, what should come to your mind? What do you think? Oxygen heat क्या कर सकता है? Free radical. Oxygen diradical. So whenever oxygen heat is given, oxygen heat, basically you are going to break this bond and create a dirad. Note down. Diradical. Diradical. Ether आपने क्या हुआ? Ether, if you recall this discussion, CH3, OCH3. And can you answer this question when it was reacting with O2 or O2H? Anyone who remembers? We made diradical. And where exactly it got attached?
No, sir, the H and H will go on.
We CH this bond. CH है यहाँ पे आया, किसी को याद आ रहा है? क्या हुआ अपने क्लास में? Yes or no? It forms COOH. If chlorine is there, CCl, CCl, CCl. Check your notes, you've done this. So it won't join here, it will join here, right? Similarly, in this case, where will it join? Can you guess? Correct answer is CH. So this is ring C, one CH3, other CH3, and here in between H and C, this will join. This compound is named as cumene hydroperoxide. What is hydrogen peroxide? Do we know hydrogen peroxide? H2O2. H2. कैसा दिखता है H2O2? HOOH, right? That's a model. It's at an angle, right? Not at straight line. So this is dihydrogen peroxide. This is hydrogen, but this part is cumene. So इसका नाम हो cumene hydrogen peroxide. So we call in short cumene hydroperoxide. Name is clear. Cumene hydroperoxide. Very important reaction for school exam also. School exam में पूछते हैं, board exam में पूछते हैं, JEE Mains. It's a simple but very important reaction. Like a Reimer-Tiemann reaction. Simple but very important reaction. Kolbe's reaction. Simple and very important reaction for all exams. Not like abnormal, which is important for advanced and all, right? ये स्कूल एग्जाम में बहुत बार आ सकती है आराम से आपको, ठीक है? So should be careful about this. Any problem in this part? Now they will provide you H plus and heat. After this H plus or heat, or sometimes they will write H3O plus heat. So meaning is same. They are giving you H plus. So what happens? The structure which is drawn here will see CH3, CH3, oxygen, oxygen, H, and one H joins here. This oxygen. See, there are two oxygens. One is this, other is this. Which is attached with H. This oxygen takes H plus. Now, what's the reason for this? Why not the other one taking H? H2O is good. Because H2O can come out after this, right? If you attach here, moreover, this oxygen and this oxygen, which has more availability of electron, this one, right? So OH2 plus will form. Please drop. This only is cumene hydroperoxide. This is cumene. And now cumene hydroperoxide is being reacted with H plus heat. अब यहाँ पे मेरी बात बहुत ध्यान से सुनना, थोड़ी देर के लिए आप लिखने वाला काम बंद कर दो. Just come to listening mode. Checking. Okay. So now, as you can see, that water can go out, but the problem here is if water goes out, you get a plus charge on oxygen. And plus charge on oxygen is a highly unstable situation. Oxygen is electronegative, but you can't put plus charge like that on oxygen. So oxygen will see left and right and see the possible options. See, water should go, that's okay, but O plus charge is not okay option. It will see, on the next carbon, I have 2 CH3s and 1 pH. Now, there is a possibility of some movement here, some migration here. So what do you think? What can migrate? Migrating ability or aptitude is H negative, pH negative, R negative. Note kar lijiye. H negative, pH negative, R negative. So H is migrating very quickly. So yeah, because if it is O plus, you can't leave it like O plus. So one option is we don't do anything. We say like this, ye ban gaya, ye mera product. But if you're heating it, this will try to rearrange. So this rearrangement is happening how? So options are, we have 2 CH3 sitting next to this position. We have 1 pH also available here, right? Out of CH3 and pH, which is a better choice for rearrange? pH. pH. H, pH and then R. R is CH3. C2H5 in any such group. So in this case, what is going to happen is this pH, see this bond. This bond joins an oxygen and this water is out. समझ में आया? इस carbon पे 3 bond, एक CH3, एक CH2 और एक pH. So pH bond goes and joins there, and due to this, can you tell me the charge of oxygen is transferred to which position? If you're breaking one bond from here and giving it to oxygen, and this is out. So oxygen lost one bond, gained one bond. This oxygen. I repeat my sentence. This oxygen lost one bond, gained one bond. No charge on it. Who is losing bond? This carbon. Bond टूट गया है. यहाँ पे क्या है? Plus charge. You had 2 options. One water removal, O plus charge. So मेरे पास एक option था. I would have drawn a ring. C, CH3, CH3, oxygen plus एक option ये. एक option मेरे पास है ring. Sorry, ring नहीं. C, CH3, CH3 plus oxygen and ring. Which is better option out of these? Which is better option out of these? Option number 2, because this is plus single lone pair support also. In all ways, this is better. This is plus on oxygen, this is plus on carbon. So migration supports pH movement. I hope that point is clear. Please write down. First, you understand this, then write down properly, and then try to draw the next outcome. So next outcome will be CH3, CCH2, on plus charge, oxygen, ring, and water is out. How many people in this, please raise your hand if it is clear. Is समझ में आ रहा है आपको? Any difficulty in this part? आराम से इसको नोट कर लीजिए. Take your time to absorb this information, because there will be 10 questions coming out on this only. I'll give you. Okay. So first you should understand this information. Don't try to remember. Try to understand each and every step. Diti, is it clear? Any difficulty in this? Yatharth, Ronak, clear? Why? pH will migrate. Okay. Why this pH is migrating to O? Because O plus, you have to take care. See, if water you remove, immediate plus charge goes on oxygen. So it needs someone who can come and take that place. So there are 3 options: CH3, CH3 and pH. I am choosing pH with this logic. Okay. Easy. Now when you do that, you reach up to this part. Everyone can reach up to this part. मैं इसको थोड़ा सा रिमूव कर रहा हूँ. ये आप लिख चुके होंगे, I guess. So we have CH3, C plus CH3, OPH. Now when you want to draw, let's say, this carbocation, if you want to draw good structure, then you should also ensure that they are at angle, right? ऐसा कुछ ऐसा बनाना चाहिए आपको, थोड़ा और अच्छा दिखेगा. Because this explains that you understand it is sp2 120 degrees. So rather than drawing plainly like this shows that you have more subject knowledge. These are small things that you can incorporate for scoring more in board exams, right? I'm not saying exactly 120, but yes, it will be of that caliber, right? Of that range. Next step, what is out here in the reaction? Water was out. Same water is still available, but it will reattach to other place. What is that other place? Carbon. अभी आपने यहाँ से remove किया था, and then you again come back to carbon this time. So what will happen because of it? What will happen because of it? It will form CH3, CH3, please check. Anyone having any issues with this? Can ask. Can I remove this? अच्छा ये लिख चुके हो already वहाँ. ठीक है? Any problem in this part? Now, if you heat it, what will be the final outcome? Can I say this will again try to give you even better option? What are the possibilities for us? So O is here. O can grab this H. What will it become at this place? CH3, CH3, CCH3, and OH here. And on this OH plus, but इससे कुछ मिला अपने को, gain हुआ इससे कुछ? Are we getting out of it something? No. Still, it has to do something. So this O can push, and this itself can be a great leaving group because this is a neutral molecule. See, ये पूरा group आराम से cleave कर सकता है. PHOH is a neutral molecule. So what will it form? Once it leave, CH3, C double bond OH plus, another CH3, and phenol. एक बार मैं फिर से पूरा ड्रॉ कर दूंगा so that clear हो जाएगा. At the end, you can remove H plus and form acetone and phenol. Now see the starting point. You started with this, and you'll end up with, you're getting this reaction, end up with CH3, COCH3 and phenol. So basically what is happening, this is the structure. In this structure, this position is getting a double bond O, and this is getting OH. And end of the story तो यही हो रहा है. Can you observe the whole process? Okay. Any issues on this part? Do you understand all the rearrangements? There are ether also, then OH also. Okay. So this is ether and this is OH. Can I say it is what kind of, or rather, which group is this? Which functional group is this? It's a ketal or hemiketal. Check. It's a hemiketal. So why will it stay in that? It will become a ketone, no? It's a hemiketal, can rearrange to ketone once you heat. Can you observe? Complete this. How many of you have drawn the whole thing? Understood this? Now I have few questions for you. Which one? This H will go. H will go as H plus and will make an acetone out of it. So your final answer is this H will, once H will leave, this will be acetone and phenol as your final answer. Okay. H plus you have used in this as a catalyst, right? You are paying it back here and reaction is over. पूरी समझ में आ गई reaction? अब मैं 4 क्वेश्चन पूछूंगा, आप चारों आंसर करने with mechanism. Let's try. Can I remove this whole thing? This step is fine. Okay, now you have O ring and OH. This O is pushing electrons. This is double bond. Carbon cannot hold 5 bonds, so this whole thing cleaves. Phenol बन गया. And ये part क्या बनेगा? CH3 double bond OH plus. At the end, H plus is paid back, which is acetone and phenol. Okay. Fine. This is protonated ketone. I am drawing ketone as the final answer. Any issues? Now, take your time, take your time. कर लिया? चलिए. Question number 1. Question number 2. Question number 3. And question number 4. Try. अगर आपने रटी होगी मैकेनिज्म तो कुछ नहीं होगा इसमें. अगर आपने समझ ली तो चारों क्वेश्चंस हो जाएंगे आपसे. That is a difference. So show all the steps of mechanism. Do it properly. Show all the steps in mechanism. Do it in separate page. अपनी notebooks बंद कर दीजिए. Write it as a small test. Write your name. कोई बात नहीं. छोड़ दे उसको अंदर रख दो. Keep everything inside. Let's see कितना आपका retention कितना है ना? Write. Keep your notes closed. Write your name and use this page. Show all 4 mechanisms. अरे पेपर आउट मत करिए. Keep it inside. Keep it inside. इसमें सॉल्व करो बेटा. उसको बंद कर दो. नोटबुक हटा दो. इस पे सॉल्व कर लो. ये आपके पास है ऑलरेडी. पीछे कुछ लिखा तो नहीं है? बिकॉज ये सबमिट करना होगा. ठीक है. राइट योर नेम एंड स्टार्ट. देखो कितने ध्यान से आप क्लास कर रहे हो. हाँ. No, use the fresh one. Because I'll take it from you. Write your name everyone and start. 4 questions and 15 to 20 minutes is fine. 15 minutes is fine. Detailed mechanism. 20 marks.
What's the what last time मेरा 10.5 marks out of those.
करो. देखो कितना आपको रिकॉल है. Think. Just think. Take your time. आराम से सोचो and see what you can do. Don't ask. रुपेश जी चेयर ले लीजिए. अरे ये मत ले, वो दूसरी वहां से ले ले भाई. हाँ चलो एक काम करता हूँ, आपके लिए इजी कर देता हूँ. Check your notes what you have done and then try to do the mechanism. Notes रेफर करके लिख पाओगे? पहले मैंने कोशिश की कि आपको खुद समझ में आ गई रहे. अब मैं दूसरी कोशिश कर लेता हूँ कि जो क्लास में पढ़ा है उसमें जो आपने लिखा है क्या वो समझ में आ रहा है? अगर मान लो नोट्स आपके पास हो तो क्या समझ में आता है? देन मैकेनिज्म हो पाएंगी. यूज इट ओपन पूरा आराम से रख लो बगल में. फिर कोशिश करो कि क्या इसके प्रोडक्ट बन पाएंगे चारों. हाँ लाइक सेकेंड स्टेप. फर्स्ट स्टेप तो हो गया. सोचिए किस केस में नहीं होगी. फाइव मार्क्स तो बहुत इजी थे इस पेपर में. एक क्वेश्चन इसमें रिएक्शन होगी ही नहीं. कौन सी? नो फोर्थ में तो हो जाएगी. सेकेंड वन देयर इज नो एच तो ये कर ही नहीं पाओगे कुछ. वेयर विल सी एच गो? सी एच में ओ एच हाउ विल इंसर्ट राइट? ओके ट्राई. At least now try and submit. Don't discuss. मैंने नोट्स ओपन करने को बोला, डिस्कशन ओपन करने को नहीं बोला. अक्षय जी, संजना जी, प्लीज डू इट योरसेल्फ. डोंट डिस्कस. आप अपने नोट्स रेफर कर सकते हो, इतनी सुविधा उपलब्ध है. अभी फोन और फ्रेंड भी मत शुरू कर दो. आपने वो यहाँ पे इंसर्ट कर दिया पीएच और इसके बीच में. चेक योर नोट्स. Where is inserted? C और H के बीच में. It's between this C and this H. You have inserted between C and this ring. So please correct it. Understand? In examination, mains, advanced जब लिखने जाओगे ना, इतने बड़े-बड़े स्ट्रक्चर बनाओगे अगर तो फिर आपको उतनी शीट ही नहीं मिलेगी, कैसे करोगे? एक पेज में तो बेंजीन बनाया आपने। क्या ही समझो।
Okay, but not for apples and all, like it's in wrong direction.
हाँ?
Yes.
No, no, no.
So why not? So if I remember correctly, so first I just continue migrate over time to the
सोचिए, यही तो सोचना है बेटा, यही तो काम दिया गया है। What have you migrated? This H migrate किया आपने और water बाहर निकाला ना। आंसर इज करेक्ट, बट माइग्रेशन शो कर दीजिए। देखो, सब में फिनॉल बनाना जरूरी नहीं है। कुछ लोग सब में फिनॉल बना के मानेंगे, ऐसा नहीं है। हर केस में फिनॉल बनना जरूरी नहीं है। फर्स्ट वन रॉन्ग, सेकंड करेक्ट, थर्ड करेक्ट, फोर्थ करेक्ट। फर्स्ट चेक करो। फर्स्ट में कई लोगों को दिक्कत आ रही। फर्स्ट देखो, आप उसको फॉलो वैसे मत करो फिनॉल बनाने के लिए। फर्स्ट इज डाई रेडिकल यू विल फॉर्म and you will insert OH here. ठीक है? Then when you attack H plus, you should reach up to this. यहाँ तक सभी लोगों ने कर लिया mostly. When you break this, plus charge is coming in on your option H or pH. So I'll choose H. In that case, it will become pH, CH plus, and then OH. Now, when water will attack on carbon, what is the product? CHOH, OH2 plus. Now H plus, if you remove, there are two OH sitting on this position, which is not possible. They will remove what? Water and form PHCHO. So first question, how many got this answer? This is the correct answer. PHCHO plus water is the answer for first one. Second question, no reaction because there's no hydrogen on this. Third question, this will break as CH3COC2H5 and this part will give you PHOH. So answer for third is PHOH plus CH3C double bond or CH2CH3. For this one, O will be inserted here. OH2 plus will form. This bond will cleave. pH will migrate. Then this will cleave. So final answer will become PHCOPH plus phenol. How many got these answers? समझ में आ गया? So you have learned all the formation methods of phenol. Clear? Ending this class on this. Please revise everything. Tomorrow we'll meet and try to complete that small part of solution, 35 minutes. The remaining time we'll try to close this topic. Okay? Done? Same time. Class timing is same.